Hello. So this is chapter 10, section 2, surface area and the parametric curve. So here we are given a curve that is given in terms of two parametric equations, x of t and then y of t. And the parameter t is bounded by alpha and beta. And you're going to take this curve, you're going to revolve it with respect to the x-axis. It's going to sweep a surface. And the question here, what is the surface, the area of that surface of rotation? So we know to find based on the area of the surface in general, we know the surface area element or differential ds is 2 pi times. In this case, it's going to be 2 pi times the absolute value of y and then times dl. dl is the arc length element. So we know we have y here because the rotation is with respect to the x-axis. But dl, in terms of parametric equations, is this. dl is the square root of x prime of t squared plus y prime of t squared dt. So when you plug in a dl into ds, so we get 2 times absolute value of y times the square root of x prime of t squared plus y prime of t squared dt. And then we integrate both sides to get the area of the surface is the integral from alpha to beta of 2 pi times absolute value of y and then times the square root of x prime of t squared plus y prime of t squared dt. So that gives us the area of the surface with where the rotation was about the x-axis. And then that's case 1. Case 2 is that we have the same the curve that is given in terms of two parametric equations, and then we still have the parameter t is between alpha and beta. Only this time the rotation is about the y-axis. So we know anytime the rotation is about the y-axis, to find the surface area of rotation, we will always have 2 pi times absolute value of x here. X is basically the radius of the circle. So 2 pi times absolute value of x, and then this is just the arc length element. So that's the difference. So let's do examples. So find the surface area of the region bounded by the parametric equations x equals t cubed, y equals t squared, and then t is between 0 and 1, revolving about the x-axis. So what I will suggest when you see revolving about the x-axis, just write down the formula right away. When it's the rotation is about the x-axis, you have to have y here, 2 pi y. And the arc length element is the same in both cases. So what do we need? We need x prime here and then a square. So x is t cubed, x prime is 3t squared, x prime squared is 9t to the fourth. We need one y prime square here. Y is t squared, y prime is 2t, and then y prime square is 4t squared. We add the 2 because it says so, and then we take the square root because it says so here. So when you get, so here we can factor out t squared. So we factor out t squared, again t squared times quantity 9t squared plus 4, all under the square root. When you take the square root of t squared, you get t, and then the other one will remain under the square root sign. So that's then the square root of x prime squared plus y prime squared, which is just this piece here. Now we take it, we plug this into the formula, we get t times square root of 9t squared plus 4 dt. We have 2 pi y here, but we cannot have two variables, y and t. So you have to replace y by t squared because y equals t squared. So just replace y by t squared. So you get a t squared times t here. And then times that. Now, so when you look at this, this then to solve this integral, you have to be a little bit think differently. So what we're going to do is we're going to let the u be 9t squared plus 4. So then du is basically 9 times 2t dt. Because we have a 2 here, and then because we have a 2 and a t, so 2t dt is a du over 9. So we divide this by 9. Now, but there is still this t square, this t square is still there. So now we know we have a 2t dt, which is du over 9. 9t squared plus 4 is u. But this t squared is still remaining. How do we solve it? We can get t squared from here. So we can solve this equation for t squared. So when you solve it for t squared, basically you bring 4 on the other side. It becomes u minus 4, and then you divide by 9, give you t squared. So this t squared is u minus 4 over 9. So now we go from t integral to the u integral. So t squared is u minus 4 over 9. 9t squared plus 4 is u. 2t dt is du over 9. Pi is still outside. So we're going to plug in everything. Change square root of u as u raised to a half. Do the distribution of u to 1/2 to u into 4. And then we end up with u to 3/2 minus 4 times u to 1/2. 9 and 1 over 9, 1 over 9, we bring them outside. So we get pi over 81 times. Now when you integrate u to 3/2, you get u to 5/2 over 5/2. You integrate u to 1/4, you get u to 3/2 over 3/2. 4 is still there. Now we go to changing variables, limits of integration. So from here, so when t is a 0, u is a 4. When a t is 1, u is 13. So our new limit of integration is going to be from 4 to 13. Okay, so after we finish integration, divide by fractions. So 5/2 becomes 2/5, 3/2 becomes 2/3, and then you plug in 13 first into this expression, and then minus, you plug in 4 into the same expression, and you work on it to end up with the final answer. Now here, so when you reach this stage, you can just use a calculator. If you want to get the decimal version, you can use a calculator to get the decimal version. But these calculations, you don't have to spend so much time doing these calculations here. Okay, thank you very much.